Oh yeah. Alrighty, so we're at that fun stage where we get to check some Backlash. As you guys can see, I still haven't taken off or put the weight covers back on. So that's because I don't want to button it up and then figure out I need to, you know, replace a ball screw somewhere. So I'm leaving them off for right now. And then once we confirm numbers, then I'll be putting them back on. But just to explain the little process here, for those that don't know, these ball screws, there's a nut that rides in there, and when you move the axes back and forth, there might be an ever so slight gap between the nut and the actual screw. What that is backlash. So, you know, the more gap you have, the less accurate a cut that you can make. So when you move 1 inch, you might go 900 thou instead of, you know, the full 1 inch. So what we're gonna do is using my nice new manual here, mates and ants, not ants, don't make the spelling mistake that I did. But if you go to page, what is this, page 243, so 243, I already got it marked. If we go here, you got Backlash. That's the very end of the page. Let's go to the next page. We go here. It explains the whole process of what to do. I think it first states that you need to go to the cold start position. I still haven't cold started this machine yet. One, because I have the weight covers off. This front guard I know has the one marker for that guy, so I can't exactly go, you know, where it needs to go. So I'm going to go without doing the cold start, and I'll just start doing it. One other thing too, the method that's described here in the maintenance manual is also covered by FadalCNC. I was just searching online. They also have the same. It's pretty much verbatim what they have in here. It's just they put it in a nice PDF. It's only a few pages. I'll try and put a link to this in the description below. But basically, you go to the machine, and let's go to manual mode, and then we're gonna type in BL for Backlash. And if you don't put any numbers there, we're just gonna go to the settings page where it's gonna show us all of those for each axis. So it shows X axes, Y axes, and Z axes. So for this, 1, 1, 1, 2, 2, 2, and 4. So basically, this is at, it says it right here, at the center position. So we're gonna do multiple tests. We're gonna do the same test in multiple locations. We're gonna check with this bed shifted over. We're gonna test the backlash here in the Y. We're gonna test it on the right side in the Y, and on the left side in the Y. That's what these numbers are. So you can actually, you know, kind of compensate it for wherever you are in the bed. You know, left, center, or I guess here it's center at the negative end and positive end. And then you'll do that for the Y, and you'll do that for the X, and then for the Z, it's only 1. You can see there. So this is what's in my machine already. I'm going to go ahead and also just to point out, I just set up my new Noga and my tense indicator. It's my very first and only tense indicator I've ever owned. So, you know, cool for me. So let's go use that fancy new tool I have, and we're going to use this. We're going to use this, and then I'll try and write it all out so I can show you guys, you know, what it looks like at different areas of the bed, and then we'll see if we need to correct these or if they're right. And then after this, we'll be one step closer to making chips. So let's get you guys set up and let's go through this. Okay, so that was really weird. Two things were happening there. You guys probably saw I was going back and forth. It was probably super boring. But with the indicator, I was going and I would touch off onto the side of the tool here. I would back off 250 thou and then come back in. And one thing that was happening was that when I brought it back in and I sat it there, it started drifting. And it started drifting, I think the maximum it went to was 1 thou, and it stayed there. And then once it was there and I pushed it back, you know, I used the pendant and I moved it back to 0, it stayed there. That's one thing that happened. And then you probably saw it in the video when you're sitting over there, that this axis suddenly just jumped over, and then it threw this error, which is, it says x-axis fault as follows, error number 18, motor overload. New messages can be seen. Let's go check this out. So if we go to manual mode, MU, type MU for menu, and then error numbers, messages. Let's see, let's go to 44 first. About 45. Servo amplifier fault. About 46. What's in there? 47. Okay. So basically the same issues. Amplifier fault on axis. I gotta figure out what this means more. So I have two issues that I'm dealing with now. I got the drift in the Y when I was moving it to 0, and then suddenly the axis fault where it was kind of freaky. It just jumped over and then stopped and threw this error. I think this is the same error that I had before when I was moving the axes back and forth, and I had to go reset that relay in the back, or that like the contactor kind of dealio back there. So I'm gonna take a break. I'm probably gonna go search on the Facebook group or ask some people who have Fadals, see what's going on here, and then I'll be back when I have an answer, or maybe when I have more information. So give me a second. Alrighty, so I'm back. It's been a couple of days. I've been digging into this guy, and I think I found my problem, or problems, I don't know. First thing is, after I had those issues here with the ball screw and then jumping around, I went to the maintenance manual, and on page 560, or actually no, this is the page I'm on right now. On page 549 is the quick checkout procedure is what it's called, but it's really the troubleshooting guide, where it's got a flow chart and it goes through different symptoms or things to look at. And so I've been going through this, you know, checking off things that either don't apply or that I check out as good. And so what I've come to the conclusion is probably a resolver issue on the x-axis. One, also because I just got this x-axis fault, and it's the same error, or I think it's actually a different error than we got before. But again, it's calling out the x-axis, and there's a resolver fault. I think before it was just saying that there was a motor overload issue. But just to give you guys, you know, some idea of what I've been doing, I've been checking voltages. If you go back to this back cabinet, if you watched my previous video, you know that this guy, the power supply, I opted not to check that when we were starting up this machine, when I was powering up the RPC back there, getting that wired in and doing all the checks and balances. And I said that I wasn't going to check that, and that I was going to assume it was good. Well, I did assume that, and luckily it is correct. So I checked the 5 volt, the plus 12, and the minus 12, and what did I get? I got 5.1, 12.2, and minus 12.2. So those are all good. I also checked a symptom, or at least something that the troubleshooting guide asked or said that the check out was this blue capacitor. It's a big guy, and that's supposed to be, I think, between 130 and 165 volts. And so I checked it, and what did I get? I got 123.8 volts DC. So you can see that, hey, that's a little low. So I kind of fixed it. I kind of just guessed, and I was kind of right, I guess. But I got 128.9, which is pretty close to 130, and that's when I wired up that one capacitor in the phase converter. There's that one little capacitor on the bottom that I took the wires out of because I wanted to get the incoming voltage, the average, a lot better. It was good before, but I wanted to make it better, and I decided to add that, and luckily, I don't know if it's luck or if it just happened to be that way, but I got to 128.9. I'm going to say that's good for right now. I also talked to the guys at FadalCNC. They said it's probably good for right now, so I'm going to roll with it. What's the next thing I checked out? Oh, so Backlash. So I was going into the Backlash, and so you can see here, this is the Z-axis. Go and touch off of something solid. You know, you could do it on the spindle itself. So touch here, back off, or back this up. Where did my indicator go? Oh, there it is. So this guy. So I check that. Check the Z, check the Y, check the X. Back it off 250 thou in each direction and back on. You can do it via the programming. You can also do it, you know, with a jog pendant. The manual says to run whatever program that makes it physically go back and forth. It's pretty much the same thing. I know some of you guys that might be, you know, diehard OEM or like buy the manual guys. So that the manual says do the program and have it do it. I just jogged it, and I thought was good results. So let's go through them. So here's my before and afters. I actually checked the Z-axis 3 times just to make sure, because I did it once, and then I went through my other axes, and then came back and I did it again and did it again. But you can see here, 1/10, 1/10, and 1/10 of deviation each time doing that. So I'm going to call that good. X-axis, you can see here, I checked in the middle, or actually the middle is not here, but I checked I checked on this side, I checked in the middle, and I checked on the other side in the front. You can see over here. So in each section of that table, I got 1/10. This actually got 0, surprising there in the middle, or on the back side. And then I got 3/10. So that's a little bit, you know, more than I thought, but I'm gonna roll with it for right now. Oh, and all these measurements too are with the predefined Backlash comps that are already in there, which I showed you guys I think before. So that's X-axis, and then Y-axis, I got middle, left side, and the right side. You can see a diagram here I drew, but basically I got 1/10, I got 0, and 0 again. So that's pretty good. Oh, and so I got the Backlash taken care of, and then I went on. I kept getting the random fault on the motor, or on the resolver. So I went and I was going through the troubleshooting guide again for that issue. And let's see here. If we go to page, let me move this over here. What page is this? Page 190. So in 190 in the maintenance manual, And also you can go on FadalCNC's website. They have the same instructions. They got, I guess, just pictures to go with it. But if you look on the bottom of the axis control cards, right down here. So these little connectors, this guy, this little bullet connector, I'll pull it out real quick. These guys, you'll want to check, you can check on the inside, put a probe tip in there, and you put a probe tip on the outside here, and that should measure 1.7 volts. I think FadalCNC says 1.7 right there, and then in the actual maintenance manual from Fadal, they say 1.77. So I checked those out to try and help diagnose the resolver issue, and I got, of course I turned the page. Let's go here all the way to the back. Here we go. So my cards are in slot 9, 10, and 11. I think, I haven't checked or verified, but I think it's X, Y, and Z. But I got 1.6 volts, 1.7 volts, and 1.8 volts. If this truly is the X-axis, I mean, that's not 1.7. It might be close enough, but I'll have to go and I think I might pull the resolver out of the motor here and check that out. But I'll leave that for the next video or a different video. But so that's where I'm at now. I think I just need to, I'm gonna pull that off. If I need to, I'm gonna go and I'm gonna order a new resolver. Actually, I'll probably order 2 of them. One to replace and one to have on standby, because reading the manual, it says that that's a high failure rate, or at least it's not uncommon for it to fail with these older machines, the DC motors that have resolvers. That's one of the components that if it goes bad, it's not unusual. So that's where I'm at now. Before I leave, I'll let you guys know I had that conversation with the previous owner, or I got in contact with the previous owner. When I bought this machine, I bought it from a equipment reseller, and they told me that the company who owned this was down in Florida, and when I was doing my work back here, you can see here, I got these little pamphlets. I got actually some, it's kind of neat, some Renishaw ball bar tests from, I don't think there's a date on here. What I got that in here is the previous customers. I won't show you it just to keep their information private, but I found their address, I found the actual business name on the paperwork, and I called them up. And they're actually really nice, and they talked to me about this machine. They talked about what they had done with it. This machine actually was in their maintenance department. It wasn't one of their production machines, so I'd like to think that means it was maybe treated nicely or not used or abused as much. So, and they also said, what else? I'm gonna keep their information private, but I'll read it off the screen. So they made, so they didn't get rid of this machine because it was bad or they had any issues, because they said it was actually a really nice machine, but the spindle wasn't fast enough. So what they were working on, they needed a 24K spindle or a high-speed spindle. I don't know what actual RPM, but I think the max to this is, this is 7,500 RPM. So it wasn't fast enough for their application. I think they said that there wasn't many issues that they had. They only had one card issue, and then they also added memory. And I think the memory is actually this guy right here, this board. But yeah, it was really nice to talk to someone about this machine and them not just blowing me off. They were really nice, and they were open and willing to communicate all their their history with this machine. So up next, probably I'm going to wrap it up, but we're going to dig into the resolver next on this axis. If we need to, probably we'll replace the resolver on the motor, And then, oh look, I got some more errors here. Z-axis fault as far, so I got some more work to do. So I got to dig into this. It's got Y-axis faults, result. Oh, look at this. I got more. So maybe I might be buying more resolvers. I don't know. But I'm gonna dig into this some more off camera, but thanks for following along. Feel free to like this video or subscribe, or, you know, leave a comment on, you know, maybe what you think, or maybe, you know, if I'm missing something that you think I should look into, let me know. But anyways, thanks for following along. Thanks for following my journey, and I'll see you guys in the next one.